Welcome back. Well, last week we managed to complete only one lecture with regard to network diagram, consists of terminology and the detail how to basically construct network diagram. And eventually, once we understand the concept, we are going to zoom in into activity on arrow or arrow diagram. And then subsequently, we are going to introduce the concept of AON diagram and eventually PDM diagram. That basically will complete our syllabus for CLO2. Let's see how fast we can go. Okay, with this slide. Okay, first thing first, let's explain about this slide. This slide basically is for us to understand the concept of arrow diagram in detail. We already introduced the concept, and actually arrow diagram is quite simple since it uses finish to start relationship. So when we do the CPM calculation, we simply do the forward pass, backward pass, and eventually we are going to fill up all the values on the diagram. So activity on arrow, AOA diagram, consists of two elements. Arrow and node. Arrow and node. So arrow basically represent a task or an activity, whereas node will indicate the starting event and finishing event. So basically, at the tail, we are going to put a node, and then at the head, for instance, we are going to end up with another node that is what we call finishing node to complete one single task or an activity. That is the way to draw those things. So this is the way to draw. We just simply name the activity, for instance, A. So the first tail of the arrow indicate the starting node, and the arrowhead indicate the finishing node. And at the bottom of the arrow, we are going to put a duration normally. So that basically a complete arrow diagram for one single activity. Okay, IJ node. All right. For instance, in our drawing, or if for instance you refer scheduling textbook, you are going to see this issue, I node and J node. For instance, if we do have starting node and then finishing node, this is what we call I node. This is what we call J node. If we do have another node, another activity, for instance, B, and then finishing node, this we basically refer to K. So I, J, K. What does this I, J, K basically mean? When, remember, the issue with regard to this node, they do share the same finishing and starting, especially in between activities, because the slot that we are going to put into the values is only one, so they do share. So in order to distinguish which value that we refer to, which activities, so IJK is the one that we normally use, because we do not spell out any activity with regard to A, B, C, D, etc. So IJK would be a generic term. Note are used to illustrate when activity precede or followed. That is what we call starting and finishing notes. Okay. For instance, this is the description of activity. The only things that we have, especially planner, scheduler, project manager, engineer, when you want to construct network diagram, so you do have to come up with a description on your own based on whatever information that you have. You do not have this drawing yet. So from the information, you are going to translate into the graphic. So how to put things into description? So you need to have list of activity. You need to have predecessor, or you can basically, instead of predecessor, you can come up with a so-called successor. It is just the other way around. For instance, let's go into the list A. So A, basically the predecessor is none. So meaning to say A is the starting activity. When you see this kind of information, we can put none, we can put nil, or we just simply put dash. So it simply means A is the starting activity. There is no other activity that come before A. As simple as that. So you are going to draw one activity that represent A. This is the activity A, because there is no other activity that comes before A. And then the listing simply say next activity will be B. And B is connected from A. Predecessor A meaning to say B is going to be connected from A. So we already have A, then we just simply draw another arrow and then close with finishing notes. So that is the drawing that we come up with based on this information. So if, for instance, we use successor instead of predecessor, so it is the other way around. For instance, what come after A? What come after A will be B. What come after B? Basically nil, none. Okay, nil, none, dash, meaning to say there's no other activity after B. So B is the last activity. So based on the information, you can still draw the network diagram. So remember, a network diagram or bar chart or LOB or whatever the diagrams or technique basically just represent the graphic of the schedule based on whatever things that we decide initially from the planning. Then we are going to attach the duration when it is going to start and end, and then you are going to choose whatever graphic. And at the end of the day, based on the information, this is how the graphic looks like. Another example. There are three activities, A, B, C, using predecessor concept, information. So again, what comes before A? None. So none. So we know that there is no any other activity prior to A. So we just simply draw an arrow, represent A, close with one note, finishing note, and then go down the list. So A already completed. Now let's go into B. B, the information say connected from A. So A is already here, the ending. So we just simply connect one arrow and then close with a finishing note for B. So now we already fulfill the second description. And last one, C. C is connected from A as well. Okay, so we can draw C, or we can just draw whatever straight line, doesn't matter, because even though this arrow does not look straight, but again, it simply represents an activity. Okay, you can draw in many different ways anyway. So when you draw like this, then people understand, oh, okay, now we do have C, C is connected from A as well. Okay, so we basically fulfill the description, and when you get the drawing right, then only your calculation, the CPM calculation, will be accurate. Otherwise, there is no use. There is no use to further doing the calculation because the drawing itself is wrong. Okay, now we do have four activities. A, B, C, D. A, basically A and B. A and B, the predecessor is none, meaning to say A and B is basically the starting activity. Well, we can draw like this to present maybe A is one of activity being done by another person. B could be on different location, slightly far away, for instance, at the end of the day, they are going to be connected. Or you can draw something like this. Start with one node and then branches out. Close with another node that represents A. And then remember, two activity can share the same starting node, but not the same finishing node. They can share different finishing node, but they can share either one, either starting node or ending node. But in this case, A basically do not have any prior activity. B also do not have any prior activity. So this could be the starting point for each, because we know each of the activity will start with 0 duration. And then we close with this one, this is B. So this is also correct, okay? And then C is connected from A and B, see? C is connected from A and B, but we are going to use different dummy is required in this kind of diagram, for instance, okay? For instance, A and B. So I can use dummy. So this is what we call, this is what we call C. This is also correct. Okay, this is also correct. Okay, but then if, for instance, D is also connected from A and B, okay, A and B, that basically will make things a little bit complicated because the dummy is only one. We might basically want to modify in a slightly different way. Okay, so that's why this drawing is being chosen. So, for instance, the one that I want to mention, basically the starting can be like this. Okay, the starting can be like this. We do have another example to represent this issue in the second, in the coming slide. Not this one, another one. Okay. So this activity, this is the one that I mentioned to you. We can basically, we can draw like this. We can draw like this. It is not wrong, because in one of the previous, I think, final exam or last semester final exam, we do have this kind of diagram at the end of the diagram. Okay, at the end of the diagram. Okay, but then you know, at the end of the day, you are going to choose a bigger value toward this what we call activity anyway. But again, in order to avoid confusion, we can draw something like this. This, for instance, the starting for K and then the ending for K, and then J. J can share the same starting with K, but then it do have different finishing. Why we need dummy? Let's say, for instance, there is one activity that need to be connected. Let's say JKL. For instance, L connected from both K and J. Okay, K and J. Similarly, we can draw L like this. Okay, from the, we understand from the calculation, we are going to choose whatever the bigger value and put into this slot there. But this is much better way of doing things. Okay, for instance, let's say K is 5 days, J is 4 days. So we know that this slot will basically chosen instead of 4, it will be 5. Where does 5 coming from? 5 is coming from this line. Okay, and 5 will be the starting day. Okay, the starting day for L. Similarly, let's say K do have 5 days, J is basically 4. Again, at the end of the day, if you do the calculation, you start from 0. 0 plus 5 equivalent to 5 here on the top there. 0 plus J equivalent to 4. At the end of the day, 5 will be chosen and put inside this box. Again, it's the same thing, but if you do have a lot of activity in the diagram, and especially using computer, IJ node, IJ and K nodes, then computer will confuse, okay? Because computer normally do not recognize activity by the name. It basically recognize activity with regard to the starting node and ending node. Similarly, we can draw something like this. Instead of K and J sharing the starting. Now K and J basically sharing the ending. Remember, they can share either one, but then we need the dummy. For instance, let's say we want to add the L activity. So it basically means the same thing. Let's say K is 5 days, J is 4 days. You see, from the calculation, we are going to start with 0. 0 plus 5 equivalent to 5 here. Or for the dummy, 0 plus 0 will be 0 here, 0. 0 plus 4 equivalent to 4. So which one is bigger? 5 is bigger. And 5 will be in this basically slot. And that is the issue with the arrow diagram, because one slot being shared with others. Later on, when we learn about AON or PDM diagram, we are going to see those value clearly, because each value stay in that particular slot for that activity only. Okay, N doesn't have any predecessor. Okay, start with one node, and N also start with another node. And then R is connected from M and basically M and N. So this is the things here. Once we you see, this is the relationship. Okay, so meaning to say this relationship now being fulfilled by the dummy activities. And how about S? S basically just connected from N, so it is okay. You see, the most important things um, uh, from the description, you are able to draw the diagram. Even though, if you notice from here, it doesn't say any dummy activity. The only activity being shown are M and RS. And how come in this diagram, suddenly dummy activity appear? That's what I mentioned to you. Dummy activity is a fake activity or artificial activities with zero duration. It is used to fulfill the what we call description of activity. Meaning to say, it basically more related to link between one activity and another. Okay, now, well, if we do have a physical class, we normally do this in the class. Okay, A, B, C, D. Okay, we start with A. So we just draw A like this. Close this one node. And then B, or B is connected from A. So A is there already. Just draw B. Okay, so now you complete two activity. How about C? C is connected from A. A is here. Okay. And C need to be connected, so we can just draw C. C. All right, so now we already completed C. And how about D? D is connected from B and C. Since B is already here, I can just simply draw one arrow there and name it D. But then D is also connected from C. C is down there. So how to fulfill this description? So that's why we need the dummy. We need the dummy. Okay, we need the dummy, and it basically fulfill the description. D is connected from B and C. I can even draw the other way around. Instead of putting D up here, I can just put D here. D. Because D had to be connected from C. C is already here. But the only thing is B. B is up there. So I can use dummy, and the arrow is going the other way around. That is very important in terms of the head of the arrow. You need to basically draw it correctly. Otherwise, it will mean different things. Once it means different things, it basically will influence the calculation. Okay, another example. A and B are starting activity. So why don't we try like this? This is A, okay, and this is B. Okay, there is maybe two different way of drawing. Okay, we can use this concept like this, also correct. Okay, A and B is here. The starting activity we know from the description, and then C is going to be connected from A. So C is here. Okay, then D is going to be connected A and B. Oh, okay. Since B is here, we can just simply connect D. But then we need to put a dummy activity in order to fill this description. You see? That is the way to draw. You just simply go one by one, step by step. You cannot get wrong, okay? Just go step by step. Start with A, then B, then C. And if, for instance, you want to double check, you can do the other way around, the reverse. You can see D. D is connected from A and B, and then because there is dummy, okay. So correct. And how about C? C is connected from A. A is there. All right. And then how about B? B is connected from nothing. So B and A is basically the starting activity. So that's why we can use this starting activity being shared by B, A, and B. Okay. So arrow diagram. This is how arrow diagram is going to be constructed. You notice there is a value being added in the note there. Okay. A, B, C, D, you can read from here, but to simplify this thing, normally on the top or at the bottom, doesn't matter, whatever you draw, you need to come up with the legend so that everybody understand. Early start will be paired with early finish, see? So A and C represent forward pass. Forward pass is the calculation from the left to the right of the diagram in order to fulfill early start plus early finish. Remember, early start plus duration equivalent to early finish. So this is what forward pass is all about. And then once we get the last value here, the last value basically represent early finish of B. Okay, so we already have early finish of here, but then this thing will be changed into early start of B. So that's why I mentioned to you, arrow diagram in such a way, well, could be confused by somebody who do not understand the concept because the value are being shared. If it is only one line, it is okay. But you need to remember that there could be many arrow going into the same node. Then you need to choose. In forward pass, we are going to choose the bigger value among early finish of the previous activity, and the bigger value will then be the early start of the subsequent activities. That is the concept. Okay, now we already completed, let's say, E. E is the early finish of the last activity in this diagram, B, which is B. And then how are we going to finish up the slot here? So this slot represent late finish. And how do we get late finish? Simple. Once we already have the last value, we are going to copy, because the early finish of that activity will be the late finish of that activity as well, because it is only in one particular line. Okay, so it is very obvious. Then we are going to do the backward calculation, backward pass. And what is the purpose? Is to fill up this value. What is this value? The late start. So backward pass is basically to fulfill this one. This is the formula. Late start is equivalent to late finish minus duration. So just simply remember, for forward pass, we are going to add with the duration. Early start plus duration, we are going to get the early finish. Backward pass, we are going to subtract with duration. From where? From the late finish that we already logged in. Then eventually we are going to get the late start of that particular activity. And another issue, if it is in one line, of course, the value is going to be the same. But then if we are going to have many arrow going back into that particular nodes, then again, we are going to choose among those late start values, okay? That late start values will then eventually become the early finish of the predecessor activity. We are going to choose the lowest value, okay, in order to put into this particular box. If there are many outgoing activities, okay. So this is the description of what we normally put into the diagram, a complete diagram. So that's why in your assignment, in your test, in the final exam, please do not simply just draw diagram without a complete values, because we need all these values. This is to test your understanding. And of course, you can get the answer very fast, especially project duration, by just looking at the task activity. Remember, the project duration simply coming from the longest summation of whatever path. That is basically the answer. You can get the answer very quickly if you understand by another concept. But in order to get full marks, you need to fill up this diagram. Okay, this is example. Okay, this is example with all the notes. If you do not understand this, I do not know. So you have to go back, because everything we already put inside this example. Okay, this example consists of A, B, C, E, but then there is a dummy activities. Remember, dummy activities doesn't have any duration, zero duration. The rest basically do have duration. So how to perform forward pass and backward pass? Okay, so we already have box. You can basically put the information into the notes, providing that you have note which is big enough in order to put all the values. Otherwise, this would be sufficient. The left side of the box indicate early start, and the right side of the head, the arrowhead, indicate early finish. That is the concept. And the left side of the box indicate late start, and on the finishing notes indicate late finish. So the legend is there already, and this legend, this value will basically duplicated in term of the term into the subsequent activities. Okay, so now we are going to do the forward pass. We start with 0. And then we are going to do the calculation to fill up this box. So forward pass calculation, basically early start plus duration equivalent to early finish. This is the formula. So we start with 0. Okay, we start with 0. Always start with 0 in terms of, because at the end of the day, we are going to have the project duration, let's say 14 days. So you know that 14 days basically is the required working days in order to complete the project. If, for instance, you refer to some other textbook, instead of starting from 0, they will start with 1. Why? Because in the calendar, normally, well, there is no such thing as 0 day, isn't it? There is day number 1. That's why. So if, for instance, you start with 1, you are going to get the duration will be 15 instead of 14. So actually 15 minus 1 equivalent to 14. Still, 14 days is the working days, but in order to indicate, because normally when you draw using whatever Excel column to reflect the bar chart. So day number 1 will basically have some bar that you are going to put instead of putting 0. Okay, so don't get confused. For us to simplify things, you just simply start with 0. Okay, 0 for activity A. See, 0 plus 3. So this is the note. So please read this note. Okay, 0 plus 3 equivalent to 3, and this is the value that you put into the early finish of A. So now you already completed A. Now it goes into B. B, again, early start is 3 for B, and duration is 3. 3 plus 3 equivalent to 6. This is the calculation. So 6 is here. And then how about D? We go for D first. Why not C? Because this is the issue. There are 3 arrow that goes into node number 9. So that's why we need to complete all first, because we need to choose the bigger value among all, B, C, D. So let's go into D. D, 3 plus 6 equivalent to 9. So this is the calculation for node number 7. And now goes into node number 9. Okay, node number 9, one activity is coming from D1. D1 is basically a dummy activity, consists of 0 duration. Now we can do the calculation. 6 is the starting of activity D1. 6 plus 0 equivalent to 6. Put it here as a note. And let's say, how about if it is coming from C? C basically start day number 3. 3 plus 4 equivalent to 7. Put it here, 7. And then lastly, D2. D2 start from day number 9 and 0 duration. 9 plus 0 equivalent to 9 here. Okay, 9. So that's why 9 plus 0 equivalent to 9. And 9 is the bigger among 3 incoming arrow. That's why 9 will be put into this box to indicate the starting of the subsequent activity, which is E. Okay, because E have to wait for all to be completed. E basically cannot start on day number 6, after day number 6, because C basically require 7 days. And D basically require 9 days. That is the logic. Okay, but if, for instance, you forget about the logic, easy. Just choose the bigger among all in forward pass, and that value will be in this box. And lastly, for E, 9 plus 5 equivalent to 14. This is the value. And 14, this is what we call project completion. Project completion duration. Okay, project completion duration. This is the one that we normally ask question for. Okay, see, and then forward pass already completed, because once you fill in the box on the left side of the box, so you already perform the forward pass. Now we can perform backward pass to complete all the box. Okay, how do we do that? We copy this, the last value of the early start, early finish, into this box. This will be the late finish value. And remember, the backward pass is for us to do the calculation by subtracting with D. We are going to get the late start. How do we do that? Okay, for E, 14. See, the example is already shown here. 14 minus the duration here. 14 minus 5, of course, it is going to be equivalent to 5 because it is coming from the same line. Okay, so now we already complete node number 9. Now, let's go into node number 5. Remember, D1 is 0. So 9 minus here, this is the calculation. 9 minus 0 equivalent to 9. This is the value that will be inside the box. And how about D2? D2, remember, 9, this 9 minus 0, 9 minus 0 equivalent to 9. 9 will be here. Okay, now this is the issue. Because there are 3 what we call arrow that coming back from B, C, and D. So we need to evaluate each of them. This is how to evaluate. Okay, let's say it is coming from B. This is coming from B. You see, 9 minus with 3. 9 minus 3 equivalent to 6. One value. We just simply put it here, 6. How about if it is coming from C? So again, 9, this 9 minus with 4. See, this is coming from C, and we get 5. 5 is here. And lastly, for D, so 9 here, 9 minus 6 equivalent to 3. See, you can see those value clearly if you put a note, okay, like this. This is coming from for D, for instance, the calculation. And you know that 3 is the smallest among all, and 3 will be locked here. And once you get this value and the rest, you just subtract with the duration. 3 minus 3 for A will be 0. And now we start with 0. We are going to come back with 0. That is a check. Okay, that is a check. Because sometimes when you have a big activity in the network diagram, you can get confused in such a way that when you go back into the starting point, you might not get the 0. So meaning to say somewhere along the line, you might make a mistake. Maybe in terms of choosing the lowest value or choosing the largest value, or you might basically make mistake in subtracting something. So this is the diagram. Okay, this is the diagram. Okay, once we complete the early start, early finish, late start, late finish value, what else can we do in order to properly complete the CPM calculation? Remember, we can calculate total float and then free float. Total float and free float. Okay, let's calculate total float using this formula. Late finish minus early start minus duration. You cannot go wrong with this calculation if you apply into the AOA diagram. Okay, remember, let's focus on activity B. Okay, this activity B, this activity. So the value is there already in the box. Which one is late finish for B? This is the late finish. Which one is the early finish of B? This is the early finish. You see? All this value is there already. So what you need to do is basically just late finish is 9, early finish is 3, and the duration for D is basically 3. So the answer will be 3. This is the total value for B, 3. Okay? We can do the same for C. Always remember, the late finish of C is basically here, on the right side of the box. What is the early finish, early starting of C will be 3. 9 minus 3. And then what is the duration for C is 4. 9 minus 3 minus 4. So total flow will be 2. Using that formula, you can easily calculate each of the activities. And you notice that the one which basically have a thick line there, bold line, A, D, D, even D2, and E. So basically the thick line indicate something. What is something? Total float. See, for A, what is the total float? Again, we can calculate. Total float is 3 minus 0 minus 3, equivalent to 0. How about for D? D, 9 minus 3 minus 6, 0, total float. D2, we don't have to bother because D2 is just a fake activity. Actually, this D2, the real activity is basically D, okay, the real D. And lastly, E. Again, 14 minus 9 minus 5, equivalent to 0. So that's why when total float is 0 for A, D, and E, they are being called critical activities. When critical activities are connected together, they are being called critical path. Okay, critical path. So in this diagram, only B and C do have total float values. B is basically total float is 3 and C is basically total float is 2. The rest doesn't have any total float. Okay, now we finish on total float. Free float. This free float. How to calculate free float? Remember I told you free float is the gap in between activities or the free time such activity have without affecting the starting or the subsequent activity. So if that is a situation or definition, we need to focus on which activity basically do have possibility in terms of gap. Okay, we don't have to focus on connecting activity, the straight away activity that connect with another activity. We know that there is no gap in between because the starting of such a subsequent activity will eventually use the finishing of the previous activity. So there is no gap in between. The only activity that we can focus on the node. The only node that we can focus is node number 9. Node number 9. The rest you don't have to bother. So meaning to say, the rest of the activity basically do have free float of 0. Okay, later on we can test. Okay, why 9? Let's erase this thing first. Erase all. Okay, so that we can demonstrate. This is the issue. We focus on this node because in this node there are 3 activity that going in from B, C, and D. And remember, if we draw in order to reflect, we can draw something like this. This is the E activity, and then there are 3 activity going inside here. Okay, 3 activity like this. We can draw something like this. Oh, sorry. What are the activity? B, C, and then D. Okay, don't bother about D1 and D2 because the real activity is basically B and C and D. Okay, now focus on B. When do B basically start? Day number 3. When basically B will finish? Well, we need to look at the duration of B. B only require 3 days. 3 days. 3 plus 3 equivalent to 6. So the early finish of B is on 6 days. Okay. And E, this is E. E, the early start of E is basically 9, as shown in this diagram. So 9 is there. So E, for whatever reason, will start on day number 9. And this is very important. Okay, now we already finished on B. How about C? C will start on day number 3 as well. And C require only 4 days. 3 plus 4, meaning to say C is going to finish on day number 7. So that is the things. How about D? D basically start on day number 3 as well. And D require 9 days, 6 days. 6 plus 3 equivalent to 9. So you notice that this is the finishing of each previous activity prior to E. So basically E do have connecting activity, B, C, and D that goes into the E. And you notice in between them, if I draw like this, you can notice this value, this value, this value, and this value with regard to this E. Okay, so B is going to be completed on day number 6, but then B is going to be connected into E as well. But E can only start on day number 9. So meaning to say, B do have free time of how many days? 9 minus 6. So in short, I can put it here, free float for B. I need to properly put the activity name because the equation do have relationship with two activities. So this is the formula. Early start of E minus early finish of B itself. This is the example formula. And this formula have to be changed according to the activity name. Otherwise, you are going to confuse yourself because this basically represent the gap in between. For instance, early start of E, 9. What is the early finish of B, which is basically 6. But the issue, this 6, it is not anywhere in the diagram unless you note down the value somewhere, then only you can see. This is unlike the arrow diagram, AON or PDM diagram that we are going to learn later on, whereby all the values belong to that activity will remain in that box. You can see clearly. If you are using this kind of formula, you can see them clearly. But if, for instance, you want to understand the concept of free float again, the only thing that I can tell you, I'm not really sure to what extent you can understand, find the gap in between two activities, especially in this kind of situation, whereby there are many activities that goes into what we call one particular node. Then we know that some one or two activity uh, will have some kind of free float, whereby one activity doesn't have the free float. Which one doesn't have the free float? And for sure, activity D. Why? Why D? Because D will start on day number 3, require 6 days, 6 plus 3 equivalent to 9. So day will finish on day number 9, and this 9 is the one is basically will be the early start of the subsequent activity E. So meaning to say in between D and E, there is no such thing as a free float, zero free float. So free float for activity D will be 0. How about free float for activity C? We know that C is going to start on day number 3, require 4 days, 4 plus 3 equivalent to 7, 7. Activity C finish on 7 days, whereby activity E will start on day number 9. So we need to say there is a gap in between 2 days. You see, B and C do have free float of 2 days, whereas D doesn't have. That is the concept, okay, that you need to understand, because in whatever assignment, test, or final exam, sure we are going to ask those values. And some of the people do not get the values, okay, for whatever reason. Actually, it is not that difficult. Okay, now this is another example, okay. Normally, example like this, list of activity is given, duration, immediate predecessor. You know that A doesn't have any previous activities, so A is the starting activity. Okay, first thing first, you can start basically draw the diagram. Okay, start with A, for instance, and then B. Okay, this is how you practice. But since we already have the answer, later on, let's go for this diagram and try to draw without looking at the answer. Okay, let's say we can go for the calculation very quick. Start with 0. This is 0 is the early start. 0 plus 2 equivalent to 2. Okay. And then for B, 2 plus 6 equivalent to 8. And then for C, we go for C first. This note number 4. This is another example whereby there are two activities coming inside note number 4, C and D. So we need to say we need to solve both C and D as well. Then only we can get the value. Okay, let's go for C. 2 plus 3 equivalent to 5. So 5 is here. In fact, the note is already mentioned there. And how about if it is coming from D? D only require 1 day, but the starting is basically 8 day. 8 plus 1 equivalent to 9. You see, the bigger value, 9, will be in that particular box. And once we have those value, then only we can evaluate node number 5, because there are two activity going into that particular node. E start from 8, day number 8 plus 6, 6 plus 8 equivalent to 14, 14 as one example. If it is coming from F, 9 plus 3 equivalent to 12. 12 is here. And between 14 and 12, 14 is the bigger value. So, lastly, G required 2 days. 14 plus 2 equivalent to 16. So, this is what we call forward pass calculation. And then duplicate this value, put it here, 16, and then subtract with duration to get the late start value. 16 minus 2 equivalent to 14. And then 14 subtract with 6 equivalent to 8. And then 14 subtract with 3 equivalent to 11. And you need to remember here, note number 3, actually there are two activity going back. Okay, one is from E and one is from D. By right, you should see which one is the lowest value. But since we already know which one is the critical path, we already know 8, it will be there. But we can do the calculation. Let's say 11. 11 minus 10, 11 minus 1 equivalent to 10. 10 is here. Between 10 and 8, which one is the smallest value? 8. When we go back or backward pass, we are going to choose the smallest value. So 8 is basically coming from this line. So that's why 8 is there. And then going into this node, again, there are two activities. One is coming from B. How to calculate B? 8 minus 6 equivalent to 2, or 11 minus 3 equivalent to 11 minus 3 equivalent to 8. 8 is here. And of course, 2 is the smaller value. Okay, 2 will be here. Okay, and 2 minus 2 equivalent to 0. Okay, now we get back the value that we start with. So now we already completed. Okay, total float. Again, total float. Very quick. Very quick. By right, you should know how to calculate total float already. Let's say for activity F, the right hand side of the value is 14 minus 9 and minus 3. Okay. So you already, the total float is basically equivalent to 2. Okay. How about for C, this one? For C, 11 minus 2 minus 3. That is how you calculate total float. How about D, 11 minus 8 minus 1. That is the total float. The rest basically do have the value of total float 0. If you don't believe me, you can calculate for A. See? A, 2 minus 0 minus 2 equivalent to 0 total float. B, but you don't have to do the calculation because you already see some indicator there. When those values are the same, when you subtract with the whatever value, you will get 0. Okay, that is a quick way of looking at things. Actually, that's why I mentioned to you, arrow diagram is very simple because it is using the finish to start relationship. The value that we get basically is the addition into the duration or the subtraction into the duration. Basically, it goes back the same things. All right. And then you can test the another one, free float. Okay, let's test the free float understanding again. Okay, focus on what activity, what node. Okay, for me, I will focus on node number 5. Why? Because there are two activity that goes into G. So meaning to say, one of them will have free float of 0, which is from here, free float is 0, for sure. You don't have to do the calculation because you know that this 14 is coming from activity E. And this 14 is also will be the starting of activity G, meaning to say E and G doesn't have any gap in between. Whatever G and whatever E finish, automatically G will follow suit immediately. So there is no free time for E. But how about for F? F will start on day number 9. 9 plus 3 equivalent to 12. So you see, 12, F will finish on day number 12, but then G will start on day number 14. So in between, there is a 2 days gap. So you know that free float for activity F is basically 2 days. And similarly, this note, you know that activity C and D is there, going into that particular node, okay? You know that C is going to be completed on day number 5, whereas D is going to be finished on day number 9. So meaning to say, the free float for C is basically 9 minus 5 equivalent to 4, whereas for D, basically free float is 0. You see? The rest you don't have to worry. A, B, E, G, the free float is 0. That is a quick way of figuring out about the free float. Not all activity do have free float, only selected. How to focus? Well, you just focus on the node which basically do have interconnected activity. Many activity connected into one subsequent activity. Then you're for sure, one of them basically do have free float of 0. The rest could have values as being shown here. Okay, this is another example. You notice that in the test, in the exam or final, we are going to give you information like this. Okay, in reality, this is what you come up with. Okay, as a planner, scheduler, project manager, engineer who basically do the planning, these are the information that you need to come up with. Then you decide you want to use what kind of diagram. Okay, diagram is just a graphic representation of your thought. Okay, this is your thinking. And now, once you get the information, you have to list down the activity name and then successor. Instead of predecessor, we can use the concept of successor. But for whatever reason, in the computer software, they always like to use predecessor instead of successor. Successor is just on the other way. It's just like the mirror. Okay, the other way you look at things. For me, it is much easier to associate with successor anyway instead of predecessor. But anyway, if it is given like this, well, you can start with A. Okay, A close with one node, and then successor is B and C. So you know that two activity B and C. So you draw something like this. You see, whatever information given, you just go step by step, and then go for B. B connected into D, not the other way around. So that is the concept of successor. Okay, that is the way you draw. So once you finish drawing, then the rest basically do the forward pass and backward pass. So you can start with 0. For A, 0 plus 2 equivalent to 2. And then for B, 2 plus 3 equivalent to 5. And then for D, 5 plus 4 equivalent to 9. And then you go down there because you do not want to mess up with the node number 7 because there are 2 incoming activities. For C, 2 plus 2 equivalent to 4. 4 plus 3 for E equivalent to 7. Now you can do the calculation. For G, 7 plus 3 equivalent to 10. put note here first. For F, 9 plus 2 equivalent to 11. So this is how you choose. 11 is the bigger value. 11 will be here. And to complete the diagram for H, 11 plus 1 equivalent to 12. So this is the project completion duration, which is 12 weeks. It depends on the unit that you being shown, week, days, etc., etc. Now it is in week. So now to complete the calculation, you just copy 12 into here and then do the rest of backward pass. 12 minus 1 equivalent to 11. 11 minus 2 for here, it will be 9. And for G, 11 minus 3 will be 8. Okay, for D, 9 minus 4 equivalent to 5. And for E, 8 minus 3 equivalent to 5. And then be careful here, because there are two activity coming back. B, 5 minus 3 equivalent to 2 as one alternative. And for C, 5 minus 2 equivalent to 3. Of course, the smallest value in between B and C will be 2. 2 will be locked here. 2 minus 2. At the end of the day, we get 0. This is what we call backward pass. Okay, now we can do the total float calculation for E, for instance. For E, total float for E equivalent to what? The bigger value here is basically late finish minus early start minus duration. You cannot get wrong with this formula. 8 minus 4 minus 3, which is 1. This is the total float. Okay. For E, and how about for G? Total float is also 1. And how about H? H, of course, 0. 0, 0, 0, 0. And for C, the total float is 1. Did you notice one thing? Total float. Okay. I mentioned to you previously the concept of total float and free float. Free float is basically in between the free time that such activity have without affecting the starting or the subsequent activity. Whereas the total float basically we need to use the concept with regard to the project completion. And the total float basically is going to be shared among the activity on the same path. For instance, you notice the total float for C, E, and G basically 1, 1, and 1. It does not mean C can freely use 1 week as a total float to delay whatever activity. E also want to use 1, and G also want to use 1. No, they are sharing. Let's say, give an example. Let's say now, okay, let's say C, instead of using 2 weeks, C basically require extra 1 more weeks. So we can change this another week. Instead of 2, now this duration become 3. Remember, the total float for C is equivalent to 1. This one is also 1, and this also 1. So if C already used up the total float, okay, due to whatever reason, or certain activity might require longer period, or delay might happen, and it will affect the calculation. You see, how do you calculate? 2 now plus 3 equivalent to 5. If you do the calculation, 5 plus 3 equivalent to 8. 8 plus 3 equivalent to 11. Now, the bottom line now basically become the same as the top line. Both basically will be critical path. And you notice that once C already used up its total float, E basically will basically lose the total float. So that's why total float is being shared among activity within the line. So it is not the exclusive right of that particular activity, because everything will have will be looking in term of the project completion duration. Okay. And fortunately, since we just simply use 1 week only, so project still within 12 week of completion. But what if C now, instead of using now already use up the total float, now E also having experience, instead of 3 weeks, now E require one more additional week. Now basically we change into 4. And you see, once we change, once basically we utilize the total float more than what the the requirement, okay, from the calculation. Now automatically we already adjust the project completion. Instead of finishing on 12 days, 12 week, now we have to extend the project into 30. See, simply because we use up more than what it is uh, being spelled out for us. Okay, that is the issue. Even though C, E, and G originally do have 1 week of total float, but then if, for instance, you go beyond the available limit, then you are going to see the project completion will be affected. Even though from the beginning it looks like C, E, and G are quite safe, they do have free time, but if they use up beyond the limit, something will happen to the project. So that's why network diagram is being used, because it can basically show the impact of such delay into subsequent activity, and not only that, the project completion. Okay. All right. So you notice that the total float, if we tabulate all the values, so we can notice that the total float, or in computer software, instead of mentioning total float, it will use this different name, total slack, and the free float will be shown in free slack instead of free float. Okay, that is the term used in the software, and everything will be tabulated here as well in the software. But once we have all the value, so those value will be tabulated like this. Okay, you can see what is the early start and the early finish. And you notice that the total float here, we can draw or we can show on the diagram like this, or even in the software, you can basically tick, tick a box there in order to show the total float. And you notice the total float is there. But here, you notice that the total float is being plotted at the beginning. What does this thing mean? So this indicate early start, this is indicate early finish. But if in this situation, meaning to say this is the late start and this is the late finish, we use a different date. So that's why we do have this kind of value that we calculate before, because in the real scheduling, not all activity basically begin with the early start. Some activity could begin with the early start. The other activity could basically begin with the late start date, or some other activity could basically start in between an early start and the late start. So those kind of thing, you are going to see the usage of this total float later on when we learn about resource leveling and smoothing after the semester break. Maybe you do not understand why do we need to calculate total float. Okay, well, we can calculate the total float easily, but then what is the application? What is the usage? Later on, you will appreciate why basically we need to know, because there is issues with regard to resource utilization. That is the concept when we mentioned about the importance of planning and scheduling. One of the issue that we raise is basically optimization of resources. Okay, this is just another example. Okay, another example. You notice that there is a dummy here and dummy here. And when dummy is connected there, so for instance, activity this I do have connection from F, and also connection from E, and also connection from D. That's why when you read the drawing, you need to read the drawing from where arrow is connected. So for instance here, D basically do have connection like this. If for instance you just stop I is connected from F and E only, then the whole calculation will be wrong. I think maybe your assignment one, in your assignment one, okay, your assignment one consists of this kind of similar, what we call drawing, whereby there is a dummy that connected from a few nodes. And some people will get confused. They thought that the dummy basically stopped, the connection basically stopped from F and E only, whereby it basically connected from D up there. Okay. So this is an example again. You notice that the dotted line just simply to show the total float for each activity. And if we do have this kind of situation whereby there are many activities do have total float, meaning to say this project do have flexibility, If, for instance, only selected few, like the previous example, so meaning to say this project is very tight. We basically cannot make a mistake in whatever delay in some other activity. Otherwise, all activity could be affected. Okay, that is the concept. Okay, this is another example from the previous final exam also. Okay, even in your test later on, we are going to give you diagram like this. If we give you diagram like this, we need to say half of your problem basically solved. If, for instance, we do not give you diagram and we just give you information, I believe that some people will basically struggle in order to even draw the right diagram. Once you draw the wrong diagram, that's it. Okay, you can leave early because you're not going to get the answer anyway. So you need to be very careful and start practicing how basically you translate from the information into the right drawing. Okay, let's go into this calculation very quick. We start with 0. For A, 0 plus 7 equivalent to 7. From this diagram, the only the final answer that we want, basically, we want to know how many days project need to be completed. So 31 days, for instance. And another question would be, what is the critical path? Critical path. And if you look at the diagram, without even doing the forward pass and backward pass, you can notice this 31 is coming from where. Okay. Remember, I told you when you look at the diagram, you can identify how many paths do this diagram have. Okay. How many paths, meaning to say from the starting until the end. You notice that, let's say this path is one of the possibility. whereby the critical path could be coming from, because the value is 8 instead of 4. And where basically this path basically coming from? Is it from H or F? There could be. If, for instance, you take this value 7 plus 8 plus 8. Well, it looks like quite a big summation there. Okay. 8 plus 8 will be 17. 7 plus 7, 14 will be 30. 30 days. 30 days. But if you look at closely, this line, 8 plus 8, and then 7, very similar to the top of the concept, ADH, but then C is 8. 8 is much bigger than 7. So you know that this line will eventually end up with 31. Without doing the forward pass, backward pass, you know the answer already. So you can answer two questions. Project completion and then critical path. That is very typical question. But in order to earn all the marks, we basically do the whole calculation. For instance, for A, 0 plus 7 equivalent to 7. For D, 7 plus 7 equivalent to 14. And how about this note? Okay, C, 0 plus 8 equivalent to 8. Then for B, 0 plus 5 equivalent to 5. Or 8 plus 7 equivalent to 15. Now, you see? And then how about from A, 7 plus 0, 7. 7, 5, 15. So 15 is the bigger. Where does 15 coming from? From E and C. Now you already know. By now, you already know where is the critical path without completing. But in order to fill up the answer, okay, this line consists of many, 3 items there. One is coming from G. Let's solve G. 8 plus 6 equivalent to 14. Okay. And 14 plus 7 equivalent to 21. Okay, 21. And if it is coming from F, that will be 23. If it is coming from H, 14 plus 8 is just 22. So 23 is coming from the F. And next, K, 23 plus 8 equivalent to 31. Or at the bottom there, 14 plus 4 is just 20. 14 plus 4, okay, 20. So now the project basically end up with 31. That is the project completion. So you do, you copy this thing and do backward pass. So you just need to be very careful. Okay, so that would be the things. But then if we want to calculate the total float, okay, remember total float. Total float, you just need to focus on the value. Let's say for B, this is B, okay? B, 15 minus 0 minus 5, okay? That would be 10. B basically do have total float of 10 days. Even though you notice, even though the value here on the box is the same, and normally in certain situation, if the value are the same, then that activity do have total float of 0. But that's why you need to be very careful. If you are not being careful, then you are going to get trapped. Okay, get trapped meaning to say you just simply conclude that B is total float basically 0. No, because there are some connection. This value is coming from the bottom one, not the B, because they do share the same things, isn't it? That is the issue. But if you use the formula that I teach you, you should not go wrong. Okay, now let's go very quickly on what we call free float. Okay, free float, you just need to focus on note number 8, note number 7, and note number 4. The rest, you don't have to bother. They are not going to have any free float. Okay, the one which basically do have critical activities, for sure E, the free, this one basically doesn't have the free float. The only activity that do have some kind of free float are the rest. Okay, let's take a look at this is very special. 4. Okay, if you notice, 4, there are two activity coming from into 4 node, B and also A. Okay, now let's evaluate between B and F. B will start on day number 8 and number 0, and then B will finish on day number 5. Whereas activity F will start on day number 15. So the free float in between 15 and 5, the free float for B would be 10. Very similar to the total float as well. Doesn't matter. Okay, that would be for B. Very clear. And how about A? A is also connected into F. A is also connected into F with the dummy. Okay, so if you want to evaluate, for instance, A will start on day number 0, and then 7 days, A will finish on day number 7. So between A and F, it looks like 15 minus 8, minus 7 will be 8. Is that the right free float for A? And you notice that A is also connected into D. Here, this is the main what we call indicator that you need to look at as well. A is not only connected into F, but A also connected into D. And A will finish on day number 7, and immediately D will basically start on at the end of day number 7 as well. So meaning to say, between A and D, A do not have any free float. And since A do not have any free float, similarly, A basically do not have any free gap in between A and F as well, because it is not possible. Okay, we need to remember that the concept of gap in between activity, but there is also connecting activity A and D, and then A and F. So meaning to say, we are not going to have any free float for A. We are in this kind of situation, we are going to use the lowest free float indicated, meaning to say between A and D, the lowest free float is basically 0. So that, because there is only one free float for each activity, cannot be 2, cannot be between A and D 0, between A and F is basically 8. No. We need to choose only one, because free float only one. This is a classic example of what we call a proper evaluation. If you do not understand the concept, then perhaps you will say there is a free float between A and F, whereby A is also connected from some into some activities. Okay, lastly, the example for this slide, basically, let's say we want to construct network diagram starting from scratch. Okay, we normally have to look at the drawing. This is what planner, scheduler, engineer, project manager have in terms of information. Drawing only. You just imagine you are in the position of contractor organization. Contractor is the one that normally construct the scheduling, not any other parties, because they are the one that need the information. So they need to look at the specification. Where can you get this thing? This all from the contract document. And of course, knowledge. Knowledge is not in the contract document. It is from your experience. Available resources. Available resources is the one that you plan to bring in. If, for instance, from your schedule, from your calculation, and you are very tied up with regard to the time constraint, you need to get information, the resources as what the schedule require, by hook or by crook. And then constraint. Take a look at what are the date. For instance, in Malaysia, we do have all kind of holidays. Normally, in that particular holiday, nobody want to work. and why basically on earth you want to basically schedule a work, okay? Especially construction. Other industry, that will be different story. And then what else? WBS. Why you need WBS? Because you need to come up with the list of tasks or activities. And after you get the task, of course, you need to calculate the duration. Duration, how do you calculate the duration? From the concept of productivity. We already mentioned in the previous slide, productivity rate, okay? And you do the calculation, and this duration had to be tied up with the resources. Remember the example that we gave you last week with regard to removing excess soil. Okay, that is a classic example where we tie up the productivity with the resources, and at the end of the day, we are going to log in terms of how many days we can complete the task. Okay, and then we can assign the logic using whatever the type of relationship. But if we are talking about AOA diagram, the only type of relationship is the finish to start. And then, of course, in real scheduling, we are not going to do it manually because activities normally involve 100,000, etc., etc. But for our class, we normally limit up to 20 activities, so we can do it manually. And then this is an example of the things that we are going to learn in CLO number 3, one of the topic. Consists of the application. Once we construct the schedule, we can see how the schedule looks like, and then we are going to see to what extent our resources is going to be utilized, and it could basically reflect a poor utilization of resources, then how we are going to optimize. So that's why we need to do adjustment. And how do we adjust? We can adjust using the available total float or free float values. That is when you see the things are going to be connected even more. Okay, let's take an example of we do have a list of activity A until P. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Not even 20, okay? And then we do have duration, maybe in days. Then we do have predecessor. It's written there. So now we are going to construct the network by going one by one. Okay, let's start with A and B. A and B doesn't have any predecessor, so they are the starting activities. So we can start with one particular node. We can name the node 10, 30, that is the node numbering. Just example. You can start with node number one, node number two, etc., etc. If you have a bigger, many tasks, you might want to start with 100, 200, 300. Why? Because you never know. You might want to basically split the activity, or you might want to insert the activity in between so that you don't have to do the whole number counting again. You can split in between 101 instead of 1,000 kind of notes. That is how you insert in between. So A and B, put the duration underneath the arrow, and then of course you are going to close with another node. And then, okay, so A and B already completed. Now we go for C. C. C is connected from A. So where is C? C connected from A. A is already there. So you just simply draw one arrow and then close with one node. So there you go. C already completed. How about D? D is also connected from A. Oh, okay, A is there. So you close with one node. Okay, and how about E? E is connected from B. Where is B? B is there, here, and you just draw one line and then close with one node. And then F is connected from B as well, close. Well, maybe the first time you draw, the line, the position of the line might not be might not look like this because you do not know the whole connection yet. It could be very messy, but that's okay. Later on, you can refine like what we did so that the drawing looks nice. Okay. If, for instance, you do that for the assignment, you have plenty of time. But in the exam test, never mind. Whatever thing that you draw, you just basically you didn't have basically to refine the drawing until it looks very nice, whereby you basically waste a lot of time. Okay, you just basically sketch as long as it is clear, it is acceptable anyway. Then, okay, let's go into G. G is connected from C. Okay, so C is already there. You just connect one line, and then H. H is connected into D. D is here already. Then you put one H and then close with one node. And then I is connected from E. E is here. So you just connect and close with one node. And J is connected from F. F is already there. So that is how you draw the line. Okay, now. Okay. Now we go into K, the rest. And K and M is very special. It's very special. Okay. So look closely how we draw K and M especially. K is said to be connected from C and H. So this is K. Why we put K here? Because H is here already. So just basically connect one arrow and then close with one node. But then K also have to be connected from C. C is up here. So that's why we can use dummy. We can indicate dummy number one. And you notice from the original description, there is no such dummy being mentioned anywhere in the listing. Because as we mentioned, dummy is not an activity. It is a fake activity. So that's why it is not listed there. But then once we do the drawing, we need the dummy in order to portray the right connection. Otherwise, if we do not add D1 here dummy, then K only will be connected with H. Then how? So that basically do not fulfill the description of the activity. Then it is wrong already. I see. This is how dummy is basically needed in arrow diagram. Okay, L. L is here, and then it is connected with I. Okay, very straightforward. Then another one, M. It's very similar to the K. K. L, M. M basically where is M? Okay, M. M have to be connected with K and I. Since K is already here, then we just draw M. Okay, but M need to be connected from I as well, and I is here. So that's why we can use dummy D2. Okay, to fulfill this description. Again, this is a classic example how suddenly this dummy basically appear in the drawing, even though in the original description does not mention anything about the dummy. Okay, so based on the description, you need to fulfill. Okay, otherwise the drawing is wrong already. So now we already completed M. N is connected. Where is N? N is connected from G, straightforward. P is connected from J, and then Q is connected from L and P. Okay, and now we close with one final notes. We start with one note and branches out with whatever connection, and we close with one note. This is a good what we call network diagram, where every activity are interconnected. It should be the way. Okay, that is the purpose of network diagram. Connected all the activities. Then only at the end of the day, we are going to see which one is the critical path, etc., etc. Okay, now we already completed those things. We want to complete the calculation. Okay, we want to complete the calculation doing the forward pass. forward pass calculation or forward pass operation is the concept of getting this value, early start, early finish, okay, for each activity. So we start with 0 and then goes into the activities until we complete this value. Okay, how do we do that? Go one by one using each activity. A, 0 plus 8 equivalent to 8. For C, 8 plus 9 equivalent to 17. Okay. For G, 17 plus 8, 25. See, very fast. Once you get the values moving. And for D, 8 plus 4 equivalent to 12. Okay. How about for B? 0 plus 7 equivalent to 7. How about for E? 7 plus 10 equivalent to 17. How about for F? 7 plus 11, 18. How about for J? 18 plus 9, 27. How about for I? 17 plus 5, 20, 22 here. How about for this note? You need to be very careful when there are two activities coming. For H, 12 plus 3 equivalent to 15. I can jot down here in order to avoid confusion. And note number 80, there is a dummy, remember? Dummy D1 with 0 duration. So it is coming from here, 17. 17 plus 0 equivalent to 17 here. This is the one of the value. So 17 is the bigger value compared to 15 from H. So that's why this value is there. And now K, and then going into this node, there are two activity going into this particular node as well. So we evaluate from K, 17 plus 7 equivalent to 24 as one value, or coming from node number 110, 22. This is dummy 2 with 0 duration. 22 plus 0, 22. So the bigger value will be 24, and 24 will be in this particular box. And then we can evaluate here, node number 130, because there are two activities coming into this node. One is from L, 22 plus 3, 25. Okay, and then P, how about P? 27 plus 4, 31. 31 is the bigger value, will be here. Okay, we'll get stuck here. And lastly, this particular node, there are three arrows going in, N, M, Q. Let's evaluate N. N is coming from here, 25 plus 12, equivalent to 37 as one value. How about for M? If it is coming from M, 24 plus 7, 31. How about if it is coming from Q, 31 plus 2, 33. So again, the biggest value is 37 coming from N up there. So now this is what we get. This is what we call project completion duration, 37 days. Okay. So by now we already answered the question, project completion. And by now we already know the critical path, because 37 is coming from what line? From that you already know. Without doing the backward pass. But again, as I mentioned, in order to get full marks, we need to complete the diagram. Then only you can see the whole issue here. Okay, now let's complete into backward pass. This value copy into this box, 37, and then evaluate the late start value by subtracting with the duration from here. 37 minus 12 equivalent to 25. That is very clear cut. For M, 37 minus 7, 30. For Q, 37 minus 2, 35. But need to be very careful when there are activity coming back. For K, straightforward, 30 minus 7, 27. Here, 110. Actually, there are two arrows coming back. One is from L, another one is basically coming from M. Okay, so this is dummy number 2 with 0 duration. 30 minus 0 is equivalent to 30 as one alternative. if it is coming from L, 35 minus 3 equivalent to 32. So 30 is smaller value and 30 will be inside this box. And for I, we can calculate straightforward, 30 minus 5 equivalent to 35. For P, straightforward, 35 minus 4, 31. For J, straightforward also, 31 minus 9 equivalent to 22. But then this is the issue. For 30, there are two arrows coming back. Again, evaluate each one of them. Coming from E, 25 minus 10 would be 15. Or 22 minus 11 would be 11. So 11 is the smaller value, goes into that particular box. And 40 here, there are two arrows coming in actually. One is coming from G, 25 minus 8, 17 as one alternative, or 23 minus 0, 23. Of course, 70 is smaller value, goes into this. And how about here? Again, two line coming in. Okay, two line coming in. One is the coming from C, 17 minus 9 equivalent to 8. Okay, as one alternative. 20 minus 4 equivalent to 16. Actually, we already know the line already. This is just to show. So 8 is the smallest one, will be here. And lastly, what goes into here? There are two lines, 8 minus 8 equivalent to 0, or 11 minus 7 equivalent to 4, you see? So 0 is coming from here, and this is the answer. So that is the how you complete the diagram, doing forward and backward path, even though from the concept, we already know where basically the critical paths coming from. Critical activities are A, C, G, and N. The critical paths are, this is what we call, this is how we write critical paths, A dash C dash G dash N. Okay. And A, C, G, N are the critical activities. When they are connected together, they are being called critical path. Okay. All right. Now, again, let's test your understanding with regard to total fluid, because those are the things that we always want to know. For instance, I focus on this diagram. Total fluid, again, on the right hand side, 30, 30 minus 17 minus 5. This is the total fluid values as quick as possible. That is the way to calculate total fluid. Always like that. Okay, for J, for instance, J, 31 minus 18 minus in here. That is the total fluid. No need to crack your head. Okay, but then how about the free fluid? This is the issue. Free fluid, again, it is very simple. You just have to find many activities that goes into the subsequent activities. For instance, you notice here, this line. There are two activities going into Q. So we need to say one of them basically do have value of free float, whereas another one basically do have free float of 0. For instance, where do you get this 31 come? Where does this 31 come from? Well, you know that it is coming from this line. So this free float is basically 0. But L do have some free float. Why? 22 plus 3 equivalent to 25. So 31 minus 5 equivalent to 6. So L do have free float of 6 days. Okay. How about J? J doesn't have any free float. Why? Because J is going to be completed on day number 27. And this 27 will be the starting of P as well. So there is no gap in between. So that's why you need to focus on this node. This node 140, yes. And 100 also, yes. And then 80 also, yes. But 80, yeah, there is a free float for H as well. And then there is no free float for K. Okay. There is no free float for K because this 24 is coming from K. And how about I. I is also connected into M as well. But again, you notice that I is also connected into L. So meaning to say, I doesn't have any free float, okay? Because I cannot be delayed even a single day because subsequently L will use whatever the finish date of I in order to start. That is how you come up with the concept of free float. Okay. All right. So this is a few example that you can try at home. Okay. What you can try, for instance, um, is basically how to draw. Okay. You know that A and B. So you know that A and B is basically the starting. So this is how you draw A and B. For instance, A and B. And then C connected from A, C. That is how you draw. Learn how to draw first. Okay. Learn how to draw first. Okay. Then let's say this diagram. This diagram doesn't have any duration. Okay. After we draw this diagram, this is how the diagram looks like. And you notice one thing, in this description, it doesn't have any dummy activity. But when we draw, we need dummy. There are two dummy appear. Why? Because to connect G, for instance, G, where is G? You see, G is connected from C and D. G is connected from C and D. That's why dummy is needed here. And similarly, J is connected from E and what? Here, E and G. J connected from E and G, see? So we need dummy number 2. Okay, that would be one thing. The ability to draw very fast, very quickly, and correctly as well. Then basically to answer the question, let's say, for instance, this diagram. If, for instance, I mentioned that each of the activity require 1 day, 1 day, 1 day, one. Each activity require 1 day. And the question is that how many days the project basically required to complete? Well, without going through the forward pass, backward pass, you can answer it very quickly by looking at the path. Where basically the path coming from the beginning until the end. And you can add the activity duration. Let's say, by looking at this, you say that it could be coming from here, here. 1 plus 1 plus 1 plus 1. So you know that the answer is 4. But how about if the line is coming from the top? Instead of A, it goes into C. And then it goes into the dummy and goes into G and J. Also 4. How about if it is coming from B? Here, B, here, B, F, I, and K. Also 4. How about if it is coming from B, E, H, and goes into K? How about if it is coming from B, E, and then it goes into J, slightly less. But you notice one thing in this diagram. In this diagram, all of the line, or all of the activities are basically the critical activities. So in this example, the critical paths are multiple. It is not only one. Because any line can give you 4 days easily. This is the longest project. Okay. If, for instance, you have this kind of situation in a real project. So meaning to say, we can only conclude one thing: your project will be in a big risk, high risk, because if you slack with one activity, let's say E, okay, the rest of the project will be delayed, either one. But if, for instance, you keep the critical path to only one line, let's say A, D, G, and J, there are other activity that can be delayed as well, okay, which is okay, for instance. So that is the situation. But you need to remember, the critical path, it is not singular. It could be multiple critical paths. But we want to keep it as minimum as possible, because of this is a classic example. When you have, well, we just simply put the same, what we call duration. Anyway, if in the real situation, if you put different duration, then at the end of the day, you can see maybe there's only one longest line. Okay, another example. Another example. Okay, another example here. Again, first thing first, you need to construct the network diagram. Let's say this is the diagram that you come up with. Again, the dummy is not being shown in the description, but at the end of the day, this is what you get. Okay, this is what you get. Let's say we put each of the activity duration as one. One, 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 one. F as a one. Everything is one, one, and one, and one. Very quickly, you can identify the critical, the project duration and critical path by adding the value of the activity duration. Okay, but you need to to take the longest path. Let's say the straight line here. Straight line 1 plus 1. If you just simply add this, it's only 4. Is there any other line that more than 4? Okay. More than 4. Well, you can go A, B, here, here. 1, 2, 3, 4, 5. At the end of the day, 5 is the longest, the minimum project duration can be completed, and it basically reflected from the what we call the longest, okay, the longest path there. All right, okay. This is another example, okay. In the previous slide, okay, in the previous slide, I already mentioned to you about the path. The red in color, there are 5 paths in this diagram. A, D, F, I. Okay, it could be A, D, G, J. There will be 2 paths. And then what else? B, E, G, J. That will be the third path. It could be B, E, F, I. That will be the fourth. And the bottom one is basically C and H. There are 5 paths. But you can add the activity duration in each of the paths. At the end of the day, the longest path is only the one coming from this activity, the red in color, 25, 10, 15, and then 10. That will be 20, 35, how many days? 60 days, okay? So 60 days coming from the red colored line. And that will be the what we call the critical path, only one line, okay? Because the rest is not as long as that 60 days. One is 35, another one 50, 45, less than 60. So the only critical path is coming from this line. Okay, without going through the whole process of forward pass and backward pass. All right. This is another example. Okay. This is another example that you can try. Okay. Do we have the answer for that? Okay. If, for instance, this is just to indicate dummy. Okay. Dummy and another dummy. If we attach a figure, for instance, in terms of duration, at the end of the day, we can get the overall values for this project. Okay, that would be uh, the okay. Let me get back to